So we had someone is spotlighted. Okay, so we have started with your matrices. Matrices means what you'll have to know. It is the rectangular arrangement of rows and columns. Then you'll have to know your diagonal matrix, scalar matrix, identity matrix, then your row matrix, column matrix. What else? All the matrices types you'll have to know. Then we went into finding out your characteristic equation. How you'll have to find out your characteristic equation. For a 2 cross 2 matrix means what is the formula. 3 cross 3 matrix means what is the formula. General formula of your characteristic equation. Then we went into Cayley-Hamilton theorem. Your Cayley-Hamilton theorem, every square matrix satisfies its own characteristic equation. Okay, so we when it is satisfied, what does it imply? You can have A inverse and higher powers of A. You can find out. Okay, so all these things we have done. And then we went into finding out your eigenvalues and eigenvectors. And you have to know what is your symmetric matrix, non-symmetric matrix. Okay, symmetric matrix means A is equal to A transpose means it is symmetric matrix. A is not equal to A transpose means it is non-symmetric matrix. So you have to know that. After that, you have to find out your eigenvalues. Eigenvalues, how you'll have to do? You will do it by your synthetic division, or you can do it by a quadratic equation. Okay. If it is a 2 cross, if it is in the power 2, you'll solve it using your quadratic equation. Power 3 and more than that, then you will do it by your synthetic division. For that, you will substitute your lambda values and see whether it is equal to 0. Then you put that values and substitute and get your value. Okay, so that value, whatever you're getting, will become your eigenvalues or the roots of that characteristic equation. After finding out the roots, what you have to do? You have to find out your eigenvectors for each lambda value. That is, each root which you have got, you will find out your eigenvector. So till here we have finished. I will just give the same revision of the characteristic equation. Your general formula will be A minus lambda I equal to 0. And this will be your general formula. So for a 2 cross 2 matrix means it will be lambda square minus S1 lambda plus S2 equal to 0. I am repeating this characteristic equation again and again so that you will remember. Okay, at no cost, you must not forget this formula. You have to remember this formula. If you forget this formula, this full topic, whatever is there in the matrices, you won't be able to do. Okay, so for a 2 cross 2, this will be the formula. 3 cross 3 matrix means the formula will be lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Okay, definitely you have to know all the formula. These two formula definitely you have to know. You need to know what is your S1, what is your S2. Similarly, your S1, S2, S3. You have to know what is your S1. S1 is the sum of the main diagonal elements. S2 will be the determinant of A. The given matrix, you find out your determinant. Similarly, for your 3 cross 3 matrix, S1 will be the sum of the main diagonal elements. S2 will be the sum of the minus of the main diagonal elements. Okay? And S3 will be the determinant of A. Okay? So this is your characteristic equation. We will do more problems in your eigenvalue and eigenvector. So write the question, put today's date. The question. Find the eigenvalue and eigenvectors. Find the eigenvalue and eigenvectors of the matrix. I'll write the matrix. This is a 3 cross 3 matrix. 1, 0, minus 1, 1, 2, 1, 2, 2, and 3. So, right, find the eigenvalues and eigenvectors of the matrix, this matrix. Matrix A is equal to 1, 0, minus 1, 1, 2, 1, 2, 2, 3. Yeah. என்னன்னா கொஞ்சம் சீரியஸா ஓவர் ஆக்டிங்கா ஷாக் இதெல்லாம் பண்ணுவாங்க பட் சார் நெவர் ஆக்ட் சார் எப்போ நெவர் டோல்ட் லைக் ஷாக்கிங் இது முடிச்சல பெர்ஃபார்மன்ஸ் ஜஸ்ட் ஸ்போக்கன் சோ ஐ லவ் ஆக்டிங் ஐ ரியலி லவ் ஆக்டிங் இன் திஸ் என்னன்னா நேச்சுரல் unnecessary. So what is your first step in your given matrix? When you find out your eigenvalues and eigenvectors, you have to check whether it is symmetric or non-symmetric. Your given matrix is symmetric or non-symmetric. Whether the given matrix is symmetric or non-symmetric. How do you see whether it is symmetric and non-symmetric? Symmetric means A is equal to A transpose. Okay, if it is non-symmetric, A is not equal to A transpose. Then it is non-symmetric. Now the given matrix is symmetric or non-symmetric. Is that?
Non-symmetric.
What?
Non-symmetric.
Non-symmetric. Very good. So first you'll have to write that. This is a non-symmetric matrix. The given matrix is a non-symmetric matrix or it is a non-symmetric matrix. Then find out your characteristic equation. Okay. In your characteristic equation, first write your formula for a 3 cross 3 matrix. Lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Always write your formula. Okay. So equal to 0. Write your formula very well. What is your S1? S1 is your sum of the main diagonal elements. Find out your sum of the main diagonal elements. You tell me. Is your S1. So when you add your main diagonal elements, 1 plus 2 plus 3. So what is it? What is your S1?
6.
6. Okay. Next, find out your minus of your main diagonal elements. Okay. Your S2 will be the minus of the main diagonal elements. Find out. What is your sum? What is your S2? So S2, it is the sum of the minus of the main diagonal elements. I've written the minus. Now you multiply, find out and tell me the value. What is the value you're getting? The first one you're getting 4. 6 minus 2, which is 4. 3 minus 2, which is 1.
Level.
2 minus 7. Very good. So your S2 is 7.
Level, ma'am.
11. How do you get 11? Oh, this is 5.
And the second diagonal is 5, ma'am.
So you're getting 11. Very good. S2 is 11. It's minus into minus. Then find out your S3. S3 is your determinant of B. Find out your S3.
6.
6 you get. This problem we have already finished, is it? Have we finished this problem already?
Yes, ma'am.
I think it is yes. If we are finished with this problem, why should we do it again? We will do another problem. We have already done this problem. You've got this problem already in your notebook. So your lambda cube minus your S1 is 6 lambda square plus 11 lambda minus 6 equal to 0. You've already done this. You've got your lambda value to be 1, 2, 3 center. Okay. You do it as a revision. You can try this. Okay. We will do another problem. This problem we have already done. Write another problem. Find the eigenvalue and eigenvectors of the matrix. Write in another page. Okay. Find the eigenvalue and eigenvectors of the matrix. 8 minus 6, 2, minus 6, 7, minus 4, 2, minus 4, and 3. 8, minus 6, 2, minus 6, 7, minus 4, 2, minus 4, 3. Have you done this problem? Have you already done this problem? If you've done it already, please tell me, okay? After I do the problem only. Okay. So first step is to see whether it is a symmetric matrix or a non-symmetric matrix. A symmetric matrix or a non-symmetric matrix?
Symmetric matrix.
It is a symmetric matrix because A is equal to A transpose. Otherwise, you can see your diagonal elements above and below. So minus 6, minus 6, minus 4, minus 4, and 2, 2. So it is a symmetric matrix. First, you have to write your symmetric matrix. Then write your characteristic equation formula. Your characteristic equation is lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. What will be your S1? S1 is your sum of the main diagonal elements. So add it. You add it, what do you get? 8 plus 7 plus 3 will be 18. So your S1 is 18. S2, sum of the main diagonal elements. So 37 minus 4 minus 4, 3 plus 8, 2, 2, 3 plus 8 minus 6, 6, 7. Find out 21 minus. Okay, so what do you get? What is your S2? Find out. Enter S2. Here is a minus sign because I have left minus. This is minus. So what do you get? Here you have 1, 5, 20. Here is another 20. So your S2 you are getting to be 45. Yes, are you getting S2 to be 45? Here you have to work really very fast, otherwise you won't have time when you do it in your city one. Put very fast. If you're not able to do it manually, do it with your calculator. Use your calculator. Are you getting S2 to be 45? Next, find out your S3. S3 is nothing but determinant of A. Okay, find out your determinant of A. Find out and tell me what you're getting your S3. And multiply 8 into 21 minus 16 minus into minus plus 6 into minus 18 plus 8 plus 2 into plus 2 into 24 minus 14. So you'll be having here there's 1 5, so 40. Here it is 1 minus 10, so it will be minus 16. And here it will be 24 and yeah, so plus 20. So this will become 0. So 40 plus 20 is 60. 60 minus 60 is 0. So your S3 is 0. Anyone got S3 to be 0? Got S3 to be 0. Now we will substitute your S1, S2, S3 in this equation. Okay. When you substitute, what you will get? Lambda cube minus your S1 is 18. 18 lambda square. And then S2 is 45 plus 45 lambda. And your S3 is 0. So this is equal to 0. So this is your equation you've got. Okay. If you want, this will become your characteristic equation without the constant term. You don't have your constant term. So when there is no constant term, what you can do? You can keep this lambda outside. You can take lambda because there's no constant term. So I will take lambda outside. So you'll be having lambda square minus 8 lambda plus 45 equal to 0. Okay, I've taken lambda outside. Why? For finding out your eigenvalues. Okay, to find out your eigenvalues. Now, since I've taken one lambda outside, one of the eigenvalue or one of the root is lambda is equal to 0. Okay, one of the root is lambda is equal to 0. And the next equation is lambda square minus 18 lambda plus 45 equal to 0. Okay, that is another equation. From here, what you can do? You can get two roots. Okay, lambda square you've got, and from here you can get two roots. Okay, you solve this equation and get your roots. So you need to get 45. Need to get 45 and multiplied. By adding or subtracting, you need to get minus 9, minus 18. Okay, so how will get 9 to the, see which value. 9 to some means it won't come. Then what else? 45, 15 threes are 15 threes are 15, yeah. So 15 threes are it will go. Okay. So when you multiply, you need to get addition, and when you add or subtract, you need to get minus. So we will put minus minus. So when you write it, lambda square, this minus 18 lambda, you will write it like this: minus 15 lambda minus 3 lambda plus 45 equal to 0. Okay. So again, now solve it. Lambda, if you take it outside, lambda minus 15. And in these two, minus 3, if I take it outside, it will be lambda minus 15 equal to 0. Okay. In both the terms, lambda minus 15 is common. So I take lambda minus 15 outside. You will be left out with lambda minus 3 equal to 0. So the other two values of your eigenvalue will be lambda is equal to 15, one eigenvalue, and lambda is equal to 3 is another eigenvalue. Okay, so the eigenvalues for this given matrix will be lambda is equal to 0, 3, and 15. Okay, for that 0, 3, and 15 eigenvalues, what you will do? You will have to find out your eigenvector. So write it down. You're finished, right? Finding out your eigenvalue, find out your eigenvector. Started from lambda is equal to 0. Put case 1 when lambda is equal to 0. When lambda is equal to 0, your a minus lambda I, that will also become 0. Okay, it is actually lambda I into x is equal to 0. Like this only if you will multiply. Now instead of this lambda, if you multiply 0, so you will be having only ax equal to 0. Okay, so your given matrix will be 8 minus 6, and instead of this x, what you will take? Your x, x1 is nothing but First one we are taking this will be x1, x2 and x3. Okay. Minus 6, 2, minus 6, 7, minus 4, 2 minus 4 and 3, x1, x2 and x3. That's equal to 0, 0 and 0. So you'll be having the equation 8x1 minus 6x2 plus 2x3 equal to 0, minus 6x1 plus 7x2 minus 4x3 equal to 0. And then you have 2x1 minus 4x2 plus 3x3 equal to 0. Take as first equation, second equation, third equation. Okay. You can take any two equations. If it is the same equation, don't take that equation. From that same equation, take one equation. Okay. Here, if you see first, second, third equation, all the three equations are different. You can take any two equations and solve it. Get your values of x1, x2, and x3. Okay. We will take first equation and second equation. Whichever is easier to calculate, take that equation. Okay. Since here it is 6, 7, and any equation. Have you all finished writing? Say, have you all finished writing? You finished writing? Solve it. So how do you solve it? You will do it by your cross multiplication. So we will take your x1, x2 and x3. So I will take your first equation and your second equation. Your first equation and second equation itself is different. So we will start it from your coefficient of x2 is minus 6, 7, and then 2, minus 4, 8, minus 6, minus 6, 7. Okay. So with whatever value you've started, you will finish it. But write it down correctly. Minus 6, 7, 2, minus 4, 8, minus 6, minus 6, 7. Okay, see to that you're writing the values correctly. If you go wrong in writing it down, you'll go wrong. Okay. So from here, find out what is your x1. x1 will be minus 6, 2, 7, minus 4 equal to x2 by 2, 8, minus 4, minus 6 is equal to x3 by 8, minus 6, minus 6 and 7. Multiply what you get. x1 by will be 24 minus 14. 24 minus 14 will be 10. Correct? It's 24 minus 14. So x1 by 10. Next is x2 by will be minus 12 and plus 32. That will be 20. Okay, so x2 by 20 is equal to x3 by 36 minus 36. So that is also 20. So it is 56 minus 36, which is 20. Throughout, if you divide it by 10, what do you get? You will have x1 by 1 equal to x2 by 2, which is equal to x3 by 2. So your eigenvector x1 is equal to 1, 2. You can simplify if it is getting divided by a common value. Okay. In the homework problem also many had done it. You have got 4, 4, 2. Okay, there you can divide it by 2. Okay, and get it as 2, 2, 1. All the three values are divided by a common value. Then you can divide it and write the final answer. So that is your x1. For this, the x1 is equal to 1, 2, 2, 2. For your eigenvalue, lambda is equal to 0. Similarly, for lambda is equal to 3, find out. This is case 1. Next, we will go on to case 2. You've all finished? Did you understand how you're finding out your eigenvector? Next, find out lambda is equal to 3. Find out for lambda is equal to 3. This is your case 2. Okay, so here what you'll be finding out, a minus 3I into x2 is equal to 0. Where your x2, we will take it as x1, x2 and x3. Okay, so again here what you'll be having, you'll be having the matrix A minus 6, 2, minus 6, 7, minus 4, 2, minus 4, 3, minus your identity matrix. You have to multiply your 3 inside. So it will become 3, 0, 0, 0, 3, 0, 0, 0, 3 into your x2 is x1, x2 and x3 is equal to 0, 0 and 0. So now you'll be having 8 minus 3 will be 5, minus 6, 2, minus 6, 7, minus 3, 4, minus 4, 2, minus 4, 3 minus 3, which is 0. First, you have to minus it. Okay, after minus it, you have to multiply it with your x1, x2, x3. Okay, after minusing, what you have to do? You have to now multiply and get the equation. So your equation will become 5x1 minus 6x2 plus 2x3 equal to 0. This will be the fourth equation. Minus 6x1 plus 4x2 minus 4x3 equal to 0. This is your fifth equation. 2x1 minus 4x2 plus 0x3 equal to 0. This is your sixth equation. Here also, if you see, your equations are not same. All the equations are different. You can take any two equations. Since your sixth equation doesn't have an x3 term, I will take that 0 term. Okay, so that your problem solving it will be. Okay, you are taking, we will solve your fifth equation, solve your fifth equation and your sixth equation. I'm taking your fifth and sixth equation. Okay, and doing your cross multiplication. So x1, x2 and your x3. So it will be 4 minus 4 minus 4 0, then your minus 6 2, 4 and minus 4. You can take any two equation. I have taken fifth and sixth equation because there is one 0 x3. Take any two equation. You can take your first two equations also. Your x1 will become x1 by 4 minus 4 minus 4 and 0 is equal to your x2 is equal to minus 4 0 minus 6 2 and your x3 minus 6 4 2 and minus 4. Okay, now you will do it. So it is 0, your x1 by plus 16, no, is minus 16, because this becomes 0. Minus into minus plus, and another minus you'll have x2 by, you'll have minus 8. Here it becomes 0. Then you've got x3 by 24, 24 minus 8. 24 minus 8 is what? 16. So it will be only 16. Okay. Now, if you see here, all the three values can be divided by 8. Huh? So all the three values can be divided by 8. So this value can be written as x1 by minus 2 is equal to x2 by minus 1 and x3 by 2. Okay, all the three values can be divided by 8. So what I do, I divide it by 8. So your eigenvector x2 is equal to, your values are minus 2, minus 1 and 2. Okay, so your eigenvector x2 is equal to minus 2, minus 1 and 2. For some people, they can get it as 2, 1, minus 2. If at all you have taken your first two equation, you could have got it like that. It is also correct. Okay, the same equation, they have got it as 2, 1, minus 2. If you've got it like that also, it is correct. So this is for lambda is equal to 3. Next step is to find out your case 3. For case 3, lambda is equal to 15, you have to find out. Okay, for lambda is equal to 15. Find out for lambda is equal to 15, your case 3. Find out for your case 3. You have to find out 8 minus 15, 7 minus 15 minus 8, 3 minus 15. Okay, when lambda is equal to 15, find out. Solve the equation. Write the equation and then solve it. Get your value. Tell me your attendance. 1. Tell me your attendance, ma. 1. Are you there? Tell your attendance. 2.
Present, ma'am.
3.
3 present, ma'am.
3 is absent.
3
Okay,
present.
ma. 4. Okay, 4.
4% ma'am.
5.
Present,
5 is
ma'am.
absent. 6. 5.
Present, ma'am.
6. 7.
Present, ma'am.
8.
8
9.
present, ma'am.
Okay, man.
9 present.
10.
10 present, ma'am.
Okay, ma. 11.
11 present, ma'am.
12.
Present, ma'am.
13.
13 present, ma'am.
14.
14 present, ma'am.
15.
15 present, ma'am.
16.
15 present, ma'am. 16 present, ma'am.
16. 17.
Ma'am, 17 present, ma'am.
18.
Ma'am. 18%, ma'am.
Okay, ma. 19.
Present, ma'am.
20.
20 present, ma'am.
21.
21 present, ma'am.
22.
22 present, ma'am.
23.
23 present, ma'am.
24.
24 present, ma'am.
25.
Present, ma'am.
26.
26 present, ma'am.
27.
27 present, ma'am.
28.
28%, ma'am.
29,
Ma'am.
30,
Present, ma'am. Present, ma'am.
31,
31%, ma'am.
31,
Present, ma'am.
32, 33,
32%, ma'am.
33,
33%, ma'am.
34,
34%, ma'am.
35,
35%, ma'am.
36, 36, 36 absent, 37,
37%, ma'am.
38,
38%, ma'am.
39,
39%, ma'am.
40,
40%, ma'am.
41,
41%, ma'am.
42, 42, 42 absent, 43,
Present, ma'am.
44,
Ma'am,
45,
42%, ma'am.
no, 42 is present, 44 is also present. Okay, 45, 45, 46, 45 is absent, 46,
Present, ma'am. 46.
47,
Present, ma'am.
48,
Present, ma'am.
49,
Present, ma'am.
50,
Present, ma'am.
51,
Present, ma'am.
52,
Present, ma'am.
53,
Present, ma'am.
55, 54, 54 is Rahul, 54 is absent, 55,
55%, ma'am.
56, 56 absent, 57,
57%, ma'am.
58,
58%, ma'am.
59, 59, absent, 60,
Present, ma'am.
126,
Ma'am, 56%, ma'am.
okay, ma'am. 126 is present, 126 absent, 127,
127%, ma'am.
128,
28%, ma'am.
okay, goes, 129,
129%, ma'am.
Ma'am,
130,
120, ma'am.
120,
6, ma'am.
okay, 126 is present, 130, Maya Kannan is absent. Okay, I will tell you the absentees. 136, 45, 54, 59, 130 is absent.
Present, ma'am.
36.
36 is present. Who else? 1 is present. Okay, so 45, 54, 59 and 130. Did you finish this problem? So your equation will be minus 7x1 minus 6x2 plus 2x3 equal to 0. Okay, this you will take it as your seventh equation. And then minus 6x1 minus 8x2 minus 4x3 equal to 0. This you will take it as your eighth equation. 2x1 minus 4x2 minus 12x3 equal to 0. You take it as your ninth equation. Take any two equations, okay? Take any two equations, solve it, and your final eigenvector. Anyone, did you finish? Tell me the final eigenvector. You can take any two equations and you have to find out what was the eigenvector you got. Tell me. I will tell you the answer. You should have got x3 is equal to 2 minus 2, 1. Okay, or it can be minus 2, 2 minus 1. Okay, for lambda is equal to 15, your eigenvector should have been this. It can be 2 minus 2, 1, or it could have been minus 2, 2, and minus 1. Okay. If you have not got, check whether you've got some multiplication mistake on it. Okay. So this is your equation. You can take any two equations, solve it, get your value. If you've got any doubts, ask me.